We're happy to share that 22 colleagues have joined from local institute, including ICDRB and others 5 national institute. So representatives from ICDRB, the hosting institute of the Global Health Network Asia, the Global Health Network, and Health Data Research Global will be coordinating the session today. So the objective of the workshop is to gain a basic understanding of R and RStudio for epidemiological tasks such as data cleaning, analysis, and presentation. So participant can bring any queries generated to monthly data clinics. So before starting the session, there are some housekeeping rules. The workshop is being recorded. Use the chat box to introduce yourself, comments, and questions. Please raise your hand to share questions verbally. We'll let you know when you can unmute. There are some certification issue. Your certificate will automatically be emailed to you, but you expect you will have full-time engagement in both of the sessions. So this is 2 days of workshop. Today we have 2 speakers. Matthew Retford will talk about the introduction to the Global Health Data Science Hub, Data Club, and Data Clinic. And then Aashna Uppal, who will facilitate the remaining of the session. Now I am introducing Matthew Retford. Matthew is a technical program manager for HDR Global, the International COVID-19 Data Alliance. He joined HDR UK in May of 2021 and is responsible for the technical delivery and oversight of HDR Global and iCoder programs and work streams. Matthew brings more than 5 years of experience in the health tech sector in the UK and Australia. Prior to joining HDR UK, Matthew was the lead product manager at the Sarah, the largest home care provider in the UK. His work at Sarah focuses on the collections of health and operational data. So Matthew holds a degree in computer science from the University of Newcastle, Australia. So I am welcoming Matthew to feel free to present your presentation.
Thank you, Simol, and welcome everyone. It's great to see everyone online and in person and from lots of different countries in Asia and around the world. I'm going to speak very briefly about the Global Health Data Science Hub that we have before you start the club. So the Global Health Data Science Hub is part of the Global Health Network's hubs. There's many different knowledge hubs focused on different areas. This one's focused on data science for health. And it's a new hub that we're working on supporting, which is great because it means that everyone is able to start from the sort of ground up. There's a lot of work and amazing research that happens all around the world. And what we're wanting to do is build a community hub to help better support networking between researchers and also share useful tools and resources for everyone. So it's a free open access hub and it's focused, like I said, around data science. We have a really great working group that helps us work on what priority areas that we should focus on the hub. At the moment, we have over 4,000 hub members, but we're wanting that to really grow and for this to be a useful resource for everyone. Our key priority topics for the rest of the year are getting started with R for health data science, which is useful, which is why I'm speaking today. And we've also highlighted that AI and machine learning are obviously big topics, and we want to understand how we can use these tools to best support health research. And then also looking at different ways of accessing data and making data available for research. So there's looking at federated approaches and different paradigms for that. The ways in which you can interact with this hub is that you can join and be a member of the hub by signing up, and that way you will get information to your email. And you can have a look at the other knowledge hubs that are available on the Global Health Network. We've got a tool there called Connect and Collaborate, which allows you to fill out a form and add yourself to the map, which has other researchers and other people on there from around the world. And it allows you to find others, maybe in your country or maybe in other countries that are working on similar topics or research. And we really welcome any contribution of work that is your own or that you found useful from others. So any tools or research publications or tutorials or websites or links or forums, anything like that that you think would be useful in the context of health data science, you're able to share that with us, and we're able to put that up. And also we'd love to highlight any of your own work. So if you do have work or projects that you're working on that you'd like to share, that is also something we're wanting to do, is we want to sort of raise the awareness of that from the work that's happening in Asia and the Global Health Network Asia as well. Next slide, if I can. So one of the things we're working on is compiling lots of information around particular topics. And I mentioned those 3 priority topics. So the first one is R and getting started with R. What we've heard from our working group and from talking with the communities is that a lot of teams are very interested in learning R and maybe have come from a different research background and maybe health workers or a different field, and you're wanting to use data and bring in more data and move away from other tools that might be Excel or other analysis. So what we're doing is we're wanting to pull together lots of useful information and curate this around R. So what we want are things like online courses, video tutorials, books that have been useful. We also want to know about events or presentations that you've maybe aware of, code and packages and communities and forums and those types of things that can help support people when they're learning R. At the moment, we're wanting to pull all of this information together, and then we'll work to pull out some of the really useful, most important resources. We're focused on things that are freely available and that are focused around health context. There's a lot of resources for learning R out there, but we think it would be useful to focus on examples where R has been used to support health research and the like. So if you do have anything like that you have used yourself, or like I said, maybe you're a great case study in using R or learning R, then we'd love to hear. There's an email there. We're planning to publish this along with a webinar as well in September, so in a couple of months. So please feel free to reach out if you've got anything. We'd love to hear from you. Next slide, please. And finally, I just wanted to give a quick overview of data science clubs and clinics, which is what you're into today. They're a new initiative, and a lot of work has been put into develop this and try to support this sort of capacity development. We find that, especially with programming, hands-on is best. So the development of clubs and clinics is trying to support that. They're going to be focused on priority areas that will be relevant. And the clinics will be supported by data experts, and there'll be sort of a drop-in style where you're able to come in maybe with your own questions, or maybe you've got a data set that you're interested in analyzing that you need some support in. And then we also want to offer certification, as Simon mentioned as well. And yeah, the clubs will be delivered first, and then the clinics will follow to help support the knowledge that you've learned from them. And we're also wanting to understand how this has impacted you. We'd love to hear some some feedback in terms of if this is being helpful in supporting your research and how we can improve the process as well. Next slide. Which leads me on to introducing you to Aashna Uppal, who is a wonderful colleague of ours and a PhD student at the moment. Aashna is part of the HDR UK Turing Wellcome PhD program and based in Oxford. She's previously worked as an epidemiologist in the Public Health Agency of Canada, focused on COVID-19 surveillance. And she comes from a biology and mathematics background and public health background. And she's a great asset because she's also herself had to learn R through her academic and professional career. And I think that that's always great when you've got people who have had to upskill in these things. So I'll leave you with Aashna to provide the training for this session. But yeah, thank you, everyone.
Thank you, Matt. Thank you. So I think I'll stand so I can just see you. Is everyone? I'll continue to pivot this way to look at folks online. But thank you, Matt, and just a quick thank you to Ikram, Shaukat, and Simon over here. This workshop could not have been possible without their help and the help of several people that you see on the screen. So they're very key people to keep in mind. So we can get started. This is, as Matt mentioned, is our plan moving forward. So the hope is this is not going to be our last time seeing you. We want to continue meeting with you on a monthly basis and help you really integrate R and RStudio into your work, whether that's for your study or for your routine analysis. We really want this to be something you end up using. So a disclaimer is that the content of this course has been developed using Applied Epi's FER handbook, which I've linked over here. There's also an offline version you can download if you want. Although we cover a few chapters here, I really encourage you after these 2 days to go to their link and see some of their other material. They've structured it in a really intuitive way. And for those of you who are familiar with epidemiology and research, it's a really good way to learn because it provides us sort of health examples. So a quick synopsis of the pre-survey. This was done this morning. So we had 18 responses, but I know quite a few responses came in after that. So this number has grown since then. But just to show that 94%, so like most of you have heard of R and RStudio before, which is great. About half of you have used it before, which is awesome. So for those of you who have used it before, you guys will be the experts in the room, really help your peers. And the average comfort level performing tasks kind of varies by task, but it averages around 2 out of 5, which is great because this is an introductory course, so we're not expecting anyone to be an expert, or it's okay if you haven't even used R before. That is totally fine, but it gives us a good idea of what we can kind of spend more or less time on based on what people are more comfortable with. But just to say, the expectation here is not that you walk away an expert in R. You'll see that these 2 days will be kind of jam-packed with information. What we really want is for you to have a toolkit and resources that you can take forward and use in your routine work. So don't worry if something is confusing. We'll have lots of help on hand, and we're kind of available, as we said, throughout those like that 6-month follow-up period to help you continue to get used to R and use it in your own work. So it's supposed to be a chill session, make friends, have fun. So we'll start off just talking about what is R and RStudio and why the heck you had to download 2 different things and not just one. So R itself is a programming language, whereas RStudio is something called a graphical user interface, which is a long term for just saying that you use RStudio to write code. You can think of it this way: R is the actual writing, RStudio is the notebook that you write in. But together, these are very, very powerful in epidemiology. You can use them to create dashboards, outbreak and situation analysis reports, and publication quality tables and figures, which are all something you've probably come across in your research. So just to check, we had asked everyone to install R and RStudio beforehand. Were there any issues, or is there anybody who hasn't yet installed? Okay. If there is anyone who hasn't installed online or otherwise, please connect with us after, and we'll help you out with it after the session. But throughout the session, you'll see that we have several times where I'll flip from presenting like this to sharing my screen and sharing RStudio. So what I encourage you to do there is, if you can open up RStudio on your own laptops and try to follow along. But if you're not comfortable doing that, that's okay. I think it's particularly hard for people online if you only have one screen. So you can just follow along with my screen in that situation. So do whatever you're comfortable with and whatever works for you. So with that, we will start with our first kind of walking through our session. So this is for folks who might have never used R before. We're going to just open up RStudio and get used to it. So I will sit back down. I will turn my camera on so you can see me. Now exit out of this. That's me. Okay. So here I encourage you to open up RStudio on your laptops. So if you open it up, let's pause for a moment there. I will ignore this update. So when you open it up, you should see something like this, a sort of crazy looking screen with lots going on. And you'll see there's kind of three distinct sections here. But what we're going to do is we're going to make it 4 distinct sections, and then we'll walk through. So if you have it open, I encourage you to go on the top left to this. Here, I'll point it on the screen over here. This new file on the top left. So if you click New File, and you open up an R script. Now all of a sudden you should have 4 distinct sections that are all crazy looking. So we'll just kind of walk through what each of these sections means. So what you've just opened up right here in R script, this top left is called your source pane. So your source pane is kind of where all of your coding happens. This is where your document lives. Any type, we open an R script, but we'll kind of see throughout the session, there are other types of documents you can open in R, but you'll always see them kind of on this top left of your screen. Right underneath that, you'll see the console. So the console is actually where the R engine is, and that's where all the coding happens. So for example, if in my source pane, I type very simply, type 1 + 1, and you can either run it by highlighting and clicking run, or a keyboard shortcut for running it is just Control-Enter. And you can see it's not running up here, right? It's actually running down here in the console. That's because the console is the engine and where all the calculations happen. That doesn't mean I can't use the console on its own. I can actually type directly into the console, like 2 + 2. There we go. It'll print out an answer. The difference is that anything in my source pane is my document, so there my code actually gets saved. If I'm typing directly into the console, the code doesn't get saved. So we'll pause for a second there, and I want you to open up R. So the engine itself. And when you open it up, mine's yellow because I made it yellow, but I think yours will be white. But you'll see that opening up R is exactly like, it looks exactly like the console here. So RStudio just takes this and adds more detail to it. So you can use R directly, but it'll just be the console, just to show you the difference between the two. So you can go ahead and close R. It'll ask you if you want to save your workspace image. Like, don't save. So there we go. So let's talk about these other 2 panes now. So you have your top right, which is your environment pane. So this is where any objects that you create in R, and we'll see these kind of throughout the session and as we go through our examples. Any object you create will be stored up here on the top right. So this is data sets, variables, and again, we'll see this in the examples. And the bottom right, finally, is the everything else pane. It's called the folders or the files, plots, and packages pane. This is where I think by default, it'll display all the packages, and we'll talk about what packages are in a moment. It'll also, if you create any graphs, your graphs will display here. Your also offers like a file viewer structure, which is very handy. So everything else is over there. So one other thing I want to show you is that sometimes, so if you've used R before, your R might not look exactly, or your RStudio might not look exactly like mine. What you can do is, if you go to the top toolbar, to Tools, and then Global Options, and you go to Appearance, you can actually change how your RStudio looks. If you want to feel like a hacker, you can change it, and it'll suddenly be dark a little bit. There you go. If you want to make it dark, you can make it dark. Whatever suits you. You can pick what theme you like, but that's just to say that you can customize it quite nicely. At the very end, I'm just going to show you really quickly how to save in R script. So over here, if you've opened something up, you'll just see that it shows untitled one, much like if you open up a new Word document, it'll just say untitled. So we can save it like you'd save any other document. There's a little save current document button over here. And you can pick where you want to save it. I just picked the desktop because I save everything to my desktop and make it messy. I'll just call it my first script. And you can see if I save it here, now it's saved as my first script. And now we can exit out of R and it will have saved. So I'll just press X and I'll exit out of R. Mine closes automatically, but yours might have closed and asked you if you wanted to save workspace image. Just click no. Saving workspace image basically saves anything you created in your environment, which isn't always necessary. So I will, and you can see it on my desktop over here. And that way it just exists in the document. I'll go back to this and just quickly review the 4 different panes that we got used to. And you kind of see any sort of R materials you see online. If you go to find more help, you'll see these terms used quite often to describe the kind of 4 sections of RStudio. So I'm going to ask you a question. What is the difference between typing code in the console pane and the source pane?
One gives saved and another doesn't.
Perfect. Online, if you didn't hear that, the answer was one gets saved and the other one doesn't. So things in your source pane get saved because that's kind of where all your documents live. Okay, now we're going to move on to talking about functions and packages. I'll stand back up so it's easy to, well, I'll close my video here so you don't just see my torso moving around. Okay, there we go. So we have functions and packages. So let's talk a little bit about what functions are. So functions are at the core of using R. If you guys are familiar with other programming languages, you'll kind of understand the concept behind functions. Functions are how you perform tasks and operations. So anything that receives an input, does something with the input, and produces an output is a function. And what's good is that there are many functions built into R. But for example, sometimes you want to perform a task and a function is not available. There are many things called packages, which I'll talk about momentarily. You can actually find functions online and download within packages. So on the screen, I have shown a very, very simple example of a function, which is the square root function. The input there is 49, the output is 7, and the sqrt over there is the actual function. So that's the general syntax. You'll kind of see a function, and then your input always goes in brackets. So functions over here is a very simple one, so it's just asking for one input. But in R, as you start coding, you'll notice that there are some functions that have multiple inputs. And that's something I think you'll see in one of your examples later today. So packages, on the other hand, packages contain functions. So on installation, R contains a bunch of base packages. So these are packages that are available with R as you install it. But many users create specialized R functions, which are verified by the R community and available on an online archive called CRAN. So these are packages that you can actually download and then use the functions within that. So once a package is downloaded, it's stored in your library. So if you remember in RStudio when we opened it, we had that packages pane on the bottom right side. So that's kind of a list of your library. So any function that, or any package that exists in your library will be available there, and you'll see over there. So what happens is after you've downloaded and a package is in your library, you can load it into your current R session to use it. So it's kind of like borrowing a book and then using it. So you can really think of R as your personal library. So you install, buy the book, and then you borrow the book to actually use it. So the library is actually a folder on your computer, and you can see that any package that you download actually exists within that folder. So I just talked about installing packages. Most often R users download from CRAN, as I said. So CRAN just stands for the Comprehensive R Archive Network. It's an online public warehouse of R packages that have been published by R community members. So there is a traditional way of installing packages. It's a two-step process. You install and then you load. Installing packages only needs to happen once, right? You buy the book once, but loading needs to happen every time you open a new R session. So you need to load your packages every time, but just install once. So the traditional way of installing a package is through this function, install.packages, as you see on the screen over there. And you have to put your package name in quotations. So in this example, we're installing a package called tidyverse, and we do that once. The traditional way of loading packages, on the other hand, is through this function called library. So over here, you put the package name, not in quotations, you just put the package name as is into library. And this helps you load the package for use. So library you have to do every time, install you have to do once. There are, however, other ways of using functions within packages without formally loading them. And for those of you who have used R before, you might notice the double colon. So double colon basically allows you to load packages and use them at the same time. So in this example here, I have loaded the read Excel package and I'm using the read_XLSX function within it at the same time. So to check whether a package is installed or loaded, you can view the packages pane, as I said, in RStudio. So if it is shown in that list, that means it's installed. But if there's a check mark beside it, that means it is loaded and ready for use. So there are other non-traditional ways of installing and loading packages. We're going to tell you about one really, really handy one. And if you go on to explore the EPR handbook, where all this course material comes from, you'll see they use this a lot. It's called the Pacman package. So it has this function called p_load that actually checks if a package is installed. If it is not installed, it'll install it for you, and then it'll load it. So now suddenly this two-step process becomes a one-step process, which is very, very handy. And you can do it for multiple packages at a time. So we really encourage the use of Pacman. So you have to install the Pacman package, and then you can use it continually to install and load a whole bunch of other packages. So it's very, very handy that way. And it kind of eliminates these extra steps. So now I'm going to ask a quick question to you. What do you think happens when I want to know more about a function? What are some things you think I can do to find out more information? And those online, feel free to chat.
You can look for the documentation.
Documentation, yeah. Okay.
Just examples.
And how do you look for the documentation?
Repositories, or there's help, and there's a help.
Yeah. Okay, nice. You notice there's a help tab in our. Just checking if online there are any other input. Oh. I can quickly show. So yeah, you're very correct in saying that you can use the help tab over here. So there's a very handy help tab on the bottom right. You can see this. I haven't searched for anything. But a cool, quick way to search in the help tab is actually, if I want to know what a function does, I can put a question mark. And let's go back to that very easy square root function, sqrt. And if I run that, it'll pull up the documentation. So the single, I think somebody had a question. Okay, we're good. So the single question mark over here will search for documentation on a function for packages that are already kind of loaded. But if you want to expand that search to packages that are installed but not necessarily loaded, you can do a double question mark. And let's say I want to know more about ggplot, which we'll learn what this function is tomorrow. But this will pull up kind of a broader search. And now you can see there's more documentation here. So it's very, very handy. And it has code demonstration, help pages. So this help pane is actually quite useful. And of course, you can see there's a little magnifying glass on the side here. You can search directly within it, but I just wanted to show you that question mark is also very, very handy. And one other super handy resource is Google. So chances are, if you have a question, somebody else out there has answered that question. I say over and over, Stack Overflow deserves my master's degree. And I see lots of people nodding. Yeah, Stack Overflow is a brilliant resource. We're going to continue to push Googling in this workshop. It's not a form of cheating. If you look at others' code, it's a great form of learning. So I wanted to actually, let me full screen this again. I wanted to actually quickly, we can pause for 5 minutes and I'll let everyone do some Googling. So these are all things that are possible in R, and I want you to quickly Google to see if you can find a good resource. For those who don't have laptops, you can share with others, but just do a quick Google search for a few minutes to see if you can find a good resource for the three of you. So it's okay if you're still Googling, but we'll just come back here and go through each of these to see, did everyone manage to find some documentation or some examples for, if not all three, at least one of them. Yeah. And what did you notice? There's like lots of different ways, right? So what's maybe an example? Did you find a function that could help you import a CSV file into RStudio? Awesome. And folks online, feel free to jump in the chat, or if you have a longer answer, you can ask to unmute, no problem. Were people successful in finding something that could help them create a histogram?
Yes.
Awesome. And how about composing a song? This one's a fun one. And I saw somebody back there. Were you Googling it?
First package for our music.
Yeah, our music. Awesome. Yeah, no, you got it. Yeah, there's multiple ways to do all of these things, and because R, I think, because it's a free resource. I think that's why there's so much documentation and so much help out there. So if anyone tells you they're good at coding, they're actually really just good at Googling. So that's something to get used to being good at, to find out exactly how to Google your question, sift through the resources and find a helpful example. So that's just to show. That's all okay. So now we'll actually go through an example. I know there's a question online about showing an example of how to use a package, so that we'll go through right now. So everyone has a link to that shared Google Drive where the examples are. I encourage you to either follow, I'll share my screen and go through it, but if you would like to open it on your end and go through on your screen, feel free to do so. It's called the Data Club _session1 example 1. It's a simple R script that we'll go through. If people are in the situation where they have not yet installed R or RStudio, feel free to just watch the screen here, and we'll share whatever you're comfortable with. So if you're just checking, folks online, is the font size big enough for you to see? If it's not, just let one of our folks in the chat box know, and then I can zoom in. So here we're kind of going to go through, this is a very short example script. You may not understand everything that's happening in terms of the code. That's not the intention. The intention of the script is just to show you how a typical R script will be organized, and some kind of good practices to keep in mind when you're doing your own. But I encourage you, you'll notice some new functions and stuff that you have not seen yet. Tomorrow, you should actually be able to understand everything that's going on in this script. So I encourage you to come back to this example after tomorrow and see if you can actually understand what the functions are doing. So the first little part of the script you'll see is a header. So anything that follows a hashtag or number sign, it doesn't have to be double, even a single one of them, single hash is enough to create a comment. So anything that follows this will not be executed as code. So it's very, very good practice to create an informative header at the top of your R scripts. You can do so with the comment function. It's important to have a title of an author. I think in epidemiology, it's very, very common to have multiple people working on analyses together. So it's very important to have the names of everyone that has contributed to the script. And of course, a last modified on. It's very important to have version control and make sure that you know who has the latest version of what analysis. So this is just good practice to have a simple header like this that has a title, author, and last modified date. Another good practice is to comment everything. I think folks that are kind of used to coding or used to working with other languages can confirm that it's so difficult to go back and read something if you have not commented, because you're thinking like, what was I doing at that time? I can't like go back into my 2-year-old brain to figure out. So commenting is a very, very handy way. It's great if you're going to be sharing your code with other people so that they can understand why you did what you did, and explain kind of step by step how your analysis is working. So typically a script after your header, the first step will always be to install packages. So over here, you can see I'm doing the shortcut of I'm installing Pacman first, and then I'm going to use the Pacman to install and load all my other libraries. So here, I'm not going to run this line because I actually already have Pacman installed, but I encourage you to run this line on your computer if you're following along. Because I already have Pacman installed, I can go ahead and run line 13. So I'm going to press Control Enter to run it, and you can see now in my console, you can see that it's run. So now it should have loaded this dplyr package. And again, you can check whether a package is loaded by going to your packages pane and seeing if there's a check mark beside it. Let me see, dplyr should, yep. See, dplyr has a check mark beside it. So it's good, it's loaded, it's ready for use. So here we're just loading one package. And now once we've loaded it, we can actually use it. So over here for this example, we'll be using the Star Wars data set. How many of you have seen Star Wars? A few. Familiar. Okay. It's okay. I also have only seen a couple of the movies, but like to use this example. So we're gonna, the first kind of step after you've loaded your package is often just to take a look at your data set. So there's a very handy function called view. So if I run this, my data set will actually open and I can see it. You can see that it's a pretty big data set. It'll show you here showing 1 to 12 of 87 entries. So there's 87 rows and 14 columns in this data set. You can see it has all sorts of information of all the Star Wars characters. In case you were curious, you can take a look. But we're going to go back to the code now. And then we have two other very, very simple functions. So this is an example of how I use a function. So now that I've loaded dplyr, this function called count actually exists within dplyr. So because I've loaded the package, now I can use the functions within it. So a very, very simple function. I go into my Star Wars data set and I count how many characters have each type of eye color. Again, don't worry about not understanding this code right now. We'll revisit this tomorrow. But I can press Command or Control Enter to run my code, and you can see it'll print out the answer here in my console. So anything that my code produces gets printed out in the console like this, as we've seen. And the last function over here, filter, is also a function that exists within the dplyr package. And again, we'll see it tomorrow. But if I run this, press Control Enter, or I press the run button, you can see that it'll print out the output over there in the console. And that's basically what a very, very simple R script looks like, the general structure over here. And again, the intention of the script wasn't to make you understand everything that's happening to the code, but just to understand the typical structure of a script. So it starts off with the header. Then you install and load any packages you intend to use. Then you kind of get familiar with your data set. And once you're familiar with your data set, now you can perform various functions and operations on it. It's a very, very simple kind of workflow. And again, I encourage you to come back to this example tomorrow. We'll actually learn what all of this gibberish means, and we'll come back. But I will pause there and see if there are any questions. Okay. Online's also okay. Yeah, if there are any questions online, feel free to ask now and we can quickly go through. Yeah, filter and count are both functions within. Exactly. You always have to install, then load the package, and then you can use the functions within. Yeah. But yeah, you'll get errors if you don't. So like right now, if I try to use, have I loaded ggplot? Oh no, I think it might have loaded. Yeah, so if I haven't loaded it, I think it should give me an error. Ah, there you go. So error in ggplot, could not find function ggplot. This is because I have not actually loaded the package that contains ggplot. And a really good thing to do with your errors is actually if you Google, now if I Google this error, chances are somebody has also not found ggplot. And you can see, Stack Overflow, fantastic. But yeah, you can see there's lots of help out there and people who have also not found ggplot, and you can see why. But yeah, that's another thing we encourage. Anytime you get an error, Google the error. There will be solutions online. Online is okay? Yeah, we're good? Okay. So I'll go back to presentation here. I think that's actually our 15-minute break time. So I think what's going to happen is for those in person, there are refreshments, and we'll kind of show you where they are. So we'll pause for 15 minutes here, and those online, you can use these 15 minutes to kind of stretch your legs, continue to ask questions, find a snack, whatever suits you. Okay. I think we'll start the next session. Hopefully everyone online is back. We'll talk about our document types and then continue from there. So what you have just done before the break was work with an R script, but remember I had said there are all sorts of other types of documents you can create in R, some of which we will see further in the session today and tomorrow. And often in epidemiology specifically, standalone scripts and other types of documents are pretty rare. So most of the time, whatever analysis you're doing will have several scripts, several data sets, several inputs and outputs. So R actually is a very handy way of making sure all of these kind of live in the same place. And it's through something called R projects. And I know R projects was one of the things that was ranked a little bit lower on the pre-course survey. People hadn't really used it before. It's not something you have to use. But it's a very, very handy way of kind of managing all of the inputs and outputs and all the scripts and files and stuff. It's a very handy way of keeping things organized as you work. So we're going to introduce it to you, but then it's up to you whether or not you want to use it. But we will encourage the use just to keep everything kind of clean. And one thing that's very sort of inherent to R is the concept of a working directory. So a working directory is that kind of folder, physical folder where everything lives. And where R will kind of refer to find any inputs into your script. So exactly as I said, R will find all things relevant to your work in your working directory. To figure out where your current working directory is, you can always type in getwd with an empty brackets into your RStudio console, and that'll spit out a file path. And that file path is where R thinks everything is, basically. You can manually specify or tell R where to find things. So you can actually fix your working directory. We don't recommend doing this manually because if you tell R where a file path on your computer is and then you share that code with somebody else, as soon as they open it, the code's not going to run because obviously your downloads folder does not exist in his computer, right? So tomorrow we'll actually see a very, very handy package that creates sort of a relative folder map to find where everything is. But for now, we'll work with our projects and kind of show you what those are like. So what I'm going to do now is we'll go again back to RStudio. So again, you can either follow along on my screen or you can open it up on your end. So I will escape from this. I will open up RStudio. So here we have a new session opened up. I'm going to ignore update. I will eventually install these updates. So in order to create a new project here, so we're going to go to File, and you'll see there's one option to create new file. There's another option to create new project. So select new project here. So you can see R is kind of loading. And what you should see pop up is the new project wizard. So here it'll give you 3 options. So how many people have used GitHub before? GitHub, some people. So you can actually connect to GitHub through R over here through using selecting version control, but we will do everything locally for now. So we're just going to simply click new directory. You click new directory, R is going to ask you what type of project you want to select. We'll go simple, new project. So over here, first you can browse to exactly where you want to store this project. So now anytime I say project, I just mean folder. So you'll see it'll create a folder on your computer. I like to store things on my desktop, as I said, so I'm just going to leave it as desktop, but you can click browse and your regular file explorer will come up so you can figure out exactly where you want to store it. And in directory name, you can give your project a name. I'm just going to call it my first project. Simple over here. And then we're going to say create project once you're ready. So I'll create project. And it looks like nothing has changed, right? It's the exact same screen, nothing happened. But over here, you can see on the top right, now it should say my first project. So now you're operating within your project, and you can see on your bottom right side on this files pane, it should now be showing the file structure for your first project. So right now, the only thing that exists in this folder is the actual rproj file. The rproj file we'll see later on. It's just something that if you double click it, it'll open up the project and start that session. That file itself doesn't contain any code. But you can see the folder is empty except for this my first project rproj file. So now anything you create within this will be saved within that package. Anytime you want to close a project, you can either go up here to the top right and say close project. Very simple. Now if I close project, now you can see our project none. So now it has defaulted back to its usual thing. If I close out of R over here, now you can see on my desktop, there should be a folder. So wherever you decided to save your project, there should now be a folder called My First Project. So just double check that that's there. And now what I encourage you to do, if you have already downloaded all the session examples and slides and stuff, so take everything that's within that session exercises and sample data folder and put it in this project folder. So I'm just going to copy all of this and drag it to my project folder. If you haven't downloaded it yet, don't worry, you can do this later. It's not gonna affect things, but this will just make sure that now all of my files live in the same place. And now you can see if I double click on my first project, just that .rproj file, I double click this, I'm gonna open up R, and now you can see just always a good way to check if you're working within a project is just check that top right corner to see if it says my first project or whatever you've named it. And now you can see the file structure. Now all of these scripts live within my project folder. So anything I create is going to live here. Any outputs that these scripts create will live here. So everything is kind of organized that way. So now I'm going to exit again, just to show you. Go ahead and close project. I'll close my R session. And I will return here. Are there any questions about that, about our project? It's clear? Okay. Online, I'll just check. Okay, cool. Now we will talk about objects. So, okay, so everything in R is an object because R, like many other programming languages, is an object-oriented language. So we're going to talk about kind of different types of objects, different structures of objects in the next couple of slides. Basically anything you create or store in R, so this can be data sets, this can be variables, even outputs like graphs. So all of these things are called objects. So they're often assigned a name and then can be referenced later in your code. And remember that top right-hand corner environment pane? That's kind of the home for all your objects. So anything you create in R will live in that top right-hand corner pane. So an object exists basically when you have assigned it a value. So when it's assigned a value, only then when will it appear in that top right-hand environment pane. And the way you assign something a value is through this arrow, so this green assignment operator. If you're familiar with other languages, you might often use like an equal sign. Yeah, so equal sign is very, very common. R uses, it's unique, it wants to be different, it uses the arrow. You can use the equal sign, it'll still work, but we don't recommend using it, it's bad practice. It technically means something a little bit different. So stick to the arrow and use that for creating variables, and we'll see this in an example shortly. So on the screen here, what you see is we're creating an object called current_week, and we're using that assignment operator to assign it a value, 2018 week 10. And then now the object current week exists, so anytime we want to reference it, we just type in current week, and that command will actually print out the value of current week. So it should print out 2018 week 10. So now that we know what objects are, we can talk about different object structures. So an object doesn't just have to be one thing. It can be a structure of a thing. And all of this will make sense once we see in an example. I know it's a little bit hard to conceptualize now, but there are several different types of object structures. In epidemiology, vectors and data frames, you'll tend to see more. So those are the ones we will focus on today. But if you are curious about the others, I do encourage you to look into them. Vectors are columns or sort of one-dimensional objects like this. So on the example here you see I'm creating an object called age. Age is a vector. And I create a vector using the C function. C is just the combine function. So anything that is within C will now be kind of glued into a line. So over here I created age. Age is a kind of is a column of numbers right now. So age is a vector. And then data frames are now two-dimensional. Data frames you've seen, if you've worked with other languages, you've seen them as data sets. These are far more common. So data frames are basically collections of vectors now. And the vectors don't have to be uniform. They don't all have to be numbers. You know, in epidemiology, we have data sets that are very, very diverse. You can have age and sex, for example, two very, very common variables. And you can see in R, I'm creating here a data set with one variable called age. And again, I'm using that little vector command to create that one-dimensional column. And then sex is also a one-dimensional column, but together, when they're squished into a data frame, now there are two-dimensional data frames. So we'll go on to see this in more examples, but just to say that you'll come across both vectors and data frames pretty often in R. So next we have object classes. So classes describe different types of data that are within your object. So why are classes important? Classes are important because you can only do certain operations with certain classes, right? So for example, if I ask you what's cat plus dog, what will you say?
It doesn't seem meaningful.
Yeah, it's meaningless, right? But then 1 + 1 is meaningful. So exactly, R works the exact same way. It cannot add cat plus dog. If it can, then robots will take over the world. I don't know. So there are several different object classes. There are some that are more commonly found than others in epidemiology. So characters, for example, characters are commonly found in things like variables like sex could be a character, hospital name, stuff like that. Numbers there's two different types of classes for numbers. So there's integers, which are whole numbers, and then numeric, which is decimal point. So age is often an integer, whereas something like height or weight could be numeric because it's got decimal points. Factors are a little bit confusing because factors are also categorical the way characters are, but the difference is that factors mean that there's an order. So a good way to think about this is BMI category, for example. So BMI category has a natural order, right? So underweight, normal, overweight, obese. Temperature, yeah. Well, I guess temperature would be number.
Numbers, yeah.
But something that's like not a number, but has an inherent order.
Something hierarchical.
Hierarchical, yeah, exactly. So BMI category, or everyone knows about like odds ratios, and odds ratios are often have a reference category. So that's another hierarchical thing that has an order, but has like a distinct category. So isn't a number. Dates are super common in epi data sets. R has very, very handy ways of dealing with dates, doesn't need a specific date format. There are lots of packages out there that can help you deal with dates. add or subtract them, change the format and stuff, which is very, very handy. The rest I'm not going to spend too long on because you don't see them as much in Epi. But if you have questions about them, we can definitely chat about it after. And you can see one data frame is both a class and a structure, which is confusing, but stick with it because data frames also have operations that you can do with them. And we'll see it tomorrow when we're introduced to a very, very fabulous package called Tidyverse, which works specifically with data frames. So I'm going to ask you a question. You can take a few minutes if you want to try and figure out what class and or structure each of these things are. People online, feel free to put your answers in the chat. But I'll let you think about it for a bit and then we'll come back in like a minute or two. Yeah. Okay. We'll come back. Anyone say what the first? Brilliant. Second one?
Vector.
Yeah, vector and integer, yeah. And then the third one. Third one's not a trick question. What are the three different classes?
Vector of type integer, vector of type logical, and vector of type date.
Beautiful. You can see one thing here I wanted to show was that dates and characters can be quite similar. So dates and characters are both used with the quotation marks, but R is very, very good at recognizing the difference. So if it sees something that looks like a date, often it'll store it as a date. Sometimes you have to tell it what kind of class it is, but often R is very, very good at recognizing dates. Very similar to Excel. I think Excel does the same thing where it recognizes when a date is being put in. So another thing I wanted to talk about before we go to the practical example is something called indexing. So indexing is something you need when you need to view parts of objects. So for example, we have an example here where we're creating an object, which is a vector called X. And X is a character vector with apple, banana, orange, but suppose we only want to extract the orange and work with that. The way we do that is through indexing. So indexing is done most commonly with these square brackets. So X, the square brackets of 3 pulls out that third value. So anything inside the square brackets is basically the position number. So that's a very handy way of pulling out parts of objects.
So the indexing starts from 1, right?
Yeah, so I think if you ever use Python and other coding languages, sometimes it starts with 0. So here it'll actually start with 1. So the positions are 1, 2, and 3 here, yeah. Also, if you're working with data frames, there are a couple of different ways to index. For example, the $sign, and we'll see this in the example after this, the $sign on a data frame will be used to access a specific column. So if we go back to our data frame here, if I say data frame $X, it'll just extract X. Yeah, exactly. So that $sign is used to work with the specific column in the data frame. Brackets, however, can also be used for data frames. In the bracket, now because the data frame is 2-dimensional, you have to specify 2 different positions, right? You have to specify the row and the column. So for example, here I'm creating a data frame called dataset. And so you can see dataset is now an object that is stored because I've used that assignment operator. So it's a data frame with X, which is the same X as above, the apple, banana, orange. And now I've added a column called Y, which is simply a number column, 1, 2, 3. And suppose I want what's in the third row, first column, I would index it as dataset because that's my object name. And in the square brackets, I would put 3, 1. And that would pull out whatever's in the third column, or third row, sorry, first column, which is orange, again, in this case. Apparently I'm creating oranges. You can also index lists, which we didn't really talk about because lists aren't as commonly used in Epi. They're a little bit more advanced. But you can also use indexing to access things within lists. And if that's something you're curious about, I'm happy to talk about it after and direct you to resources. So now we can actually, we have a good amount of time. What we can do is we can get started on some exercises. I'll encourage you to continue these exercises at home. We can get started on them, and then we can even maybe cover a couple of introductory topics from tomorrow, because tomorrow's, you'll see, is like kind of jam-packed, but like really exciting, because now that you're basic R experts, we get to do some fun stuff tomorrow and actually work with data. But here we can get started on some exercises. So again, so here, I'm going to open up. So here, because I've put everything in the My First Project folder, I'll just go ahead and open up my first project again, the .rproj file. If you haven't done that, that's okay. You can open up the actual script. So we're going to be working, so your exercises are kind of stored. You'll notice that there's two scripts. So there's Data Club Session 1, Exercise 1, Data Club Session 1, Solutions 1. I'm going to open up the solutions now just to walk through the first couple of things, but I encourage you, you can see that the exercises one, this one doesn't actually have any code in it. It just has the questions. It's not super long. So I encourage you to go through it, get kind of used to working in R, but we will get started on it together so that it's not difficult to go through. I'm going to go through the solutions over here. So here you can see same thing. We always start off with an informative header just to say what the title of the script is, what it's being used for, who created it, when it was last modified. So this is going to be standard. You can see any script that we work with will kind of have this format. And one thing to note is that you saw this when you were Googling as well. There's not one way to do things. So the solutions that we have shown here are not unique. There are other ways to do things. You can find what works for you, but we're just providing kind of one set of solutions. So here we'll start off loading the package that we need for the exercise. Over here, we're loading the package that we need is called dplyr. I'm using that shortcut way of loading it. Hopefully, if you've installed Pacman, you can just simply run this line. If you have not installed Pacman, you can go back to that first example to show how to install Pacman first. And now you can use it. And I'm just going to press Control Enter to run it. And now dplyr will have loaded. And again, you can check if dplyr has loaded. By just going to your packages, making sure there's a check mark, wherever it is. dplyr, beautiful. So it's loading. So now the next step is you're creating a data set called dataset. We're very creative here, just called dataset. And we're assigning to it so there's an existing data set called Iris that we're going to use. I'm just renaming it to dataset so it's easier to use. Iris is actually a cool data set. You can, I think I have limited bandwidth, so I won't go to this link, but you can actually read more about it here. It's all about the iris flower. It's a simple data set to use, but very cool. So you can run this line to create this data set. So one way, remember in the first example, we used the view function to pull up the data set. You can actually simply click. You'll see your mouse will kind of look like it's highlighted in the environment pane if I hover over data set. So if I click on this, it should actually open up. So you can take a look at this data set. It's quite simple. It has 4 numeric columns, one for sepal length, sepal width, petal length, petal width, and species. So species is the one sort of non-numeric column. And I say non-numeric, I'm not telling you exactly what class it is because that's one of the questions in this exercise sheet. So this is the data set that you're working with. And you can see that it has 150 rows, 5 columns. So that's usually displayed here, but it's also displayed over here. So now you actually have an object in your environment pane. So I'll go back. You can click X on this. It won't delete the data set. It'll just delete the view of the data set. So next, we're going to look at the top few rows of the data set. So the way you do that, this is very handy. Like suppose you can't really print out 150 rows and take a look. So a good way to just get a sense of what a data set looks like is using this head function, which is a function that's built into R. So if I run this in my console, it'll print out the first few rows. This is a very good way of, yeah, exactly. Just getting, yeah, first little bit, getting a little snippet, just seeing what your data set is about. Because often if you have very, very big data sets and you click view, it's a mess. It's so hard to go through. So over here, the first thing we do is look at the class of the species variable. So the species variable can also be, so class isn't unique to the data frame. You can actually figure out the class of each specific column in the data frame. And remember that I said for data frames, you can actually use the $signs to index. So now this is showing you a good example of how I'm using the $sign to index. And within data set, I'm accessing that species column. And the way to figure out what class that is simply using a function called class. So if I run this, you'll see it'll print out factor. So that means species, it's a factor, so it's categorical, but there's some sort of hierarchy built in it. There's order matters basically now. So that we know. So it's not a character, but rather it's a factor. And same thing with sepal width, for example. Now we can similarly figure out what class it is. It's a numeric. And that we saw. We saw it was a number with decimals, and a numeric makes sense. So I'm going to pause there for the exercises. I do encourage you to kind of go through the rest. We went through the first 4 questions. There are, I believe, 10 questions in this exercise sheet. They're all quite simple. You'll see like it's talking about things that we learned today, for example, indexing. Over here, it talks about kind of classes and counting, and the intention is to go over and consolidate your learning from some of the stuff we went over today. But after the first 10 questions, if you would like, especially for those who have used R before, I would encourage you to do the last 3 questions. So I believe question 11, 12, and 13. These questions here touch on something we will cover in the following session, which is a package called tidyverse, which is very, very handy for data manipulation. So these last 3 questions do touch on data manipulation. If you are curious, you can take a stab at them, but again, no pressure. It's nothing that we've covered today, so you don't have to. But for those of you who want to take it a step further, I would encourage you to do so. And we will actually have 10 minutes at the beginning, not 10 minutes, I think 20 minutes at the beginning of tomorrow's session to cover any questions that you have from these exercises. So what we're going to do is we'll email out a blank kind of Google Doc, a Google document that you can fill out your questions in before tomorrow's session. That way it'll be easier to know what to cover in that Q&A period. But if you don't have a chance to go through the exercises, that's okay. You can go through it at a future time, but it's something that we do encourage just to consolidate today's learning. So I'm going to quickly pause there for questions, and maybe I'll use the next maybe 15 minutes to get started on something from tomorrow's session, so that we have more time tomorrow to actually cover the fun stuff. So before I do that, are there any questions on the exercises? Online? It's like we're okay online. I see, yeah, Salvia, thank you. There's more information about the certificate and the certification process being shared online. Okay, cool. I will exit out of this then and encourage you, again, all materials are available through that shared drive link. I encourage you to go through the exercises, and then we will share that blank Google document via email so that you can fill in your questions as you go through, if you have questions. If you're already an expert, that's fantastic. Okay, so we're gonna skip this. So one thing we're going to quickly talk about now before moving on to tomorrow's session is importing data, because it's something that you've sort of touched on today. And then we can kind of skip this session tomorrow to cover some of the more interesting stuff. So importing data. So far we've worked with data sets that are sort of built into R, right? So we kind of just loaded the data set by calling its name, and then it like magically appeared because it was already built in. But what's more common in R, or in epidemiology, sorry, is you're working with data sets, right? You're working with disease line lists, you're working with hospital records, that sort of thing. So the way you're accessing those is by importing them into R and then kind of working with them in R. So there are lots of different ways you can import data sets. So I think if you've worked with things like SPSS or Stata, you often have to import like a specific file, right? You have like a Stata file, SPSS file, that sort of thing. In R can actually recognize all sorts of different data types or data set types. You can have CSVs, XLSX files. You can actually also have SAS data and SPSS files, and like those you can directly import into R. The one catch though is that each of these, depending on the type of data set, R will have a different function to help import it. So you saw that when you were looking at how to import a CSV, right? The function was called read.csv because it's specific to CSVs. So very similarly, there will be a function specific to XLSX files, a function specific to SAS or Stata files, etc. But there is a very, very handy way or handy package that lets you get around this. And that's called the Rio package. And I know this is one of the other things that people in the pre-course survey hadn't used much before. So the Rio package, we really, really recommend using this for importing data sets, also exporting data sets, because it has two very simple functions called import and export. And these actually detect what type of data set you're working with or what the file extension is. So that's really, really handy. Then you don't have to go in and look for a specific type of function that'll import that specific type of data set. Rio will kind of do it for you. So here it says the alternative to using this is to look at those very many other packages and many other functions. So import and export is very, very simple, easy to use, and something that we recommend. The only thing is you'll have to install Rio, load it, and then once you've installed it, loaded it, then you can kind of use the handy import export functions within it. And this I also alluded to earlier today. So the here package, remember when we opened up our projects, everything was in that one folder. And I said that, manually specifying a file path is bad practice. So the here package actually makes it very, very useful to specify relative file paths. So for example, I have a slide over here that goes through an example. So we recommend kind of anchoring your R script, and tomorrow we'll go through an example of what anchoring a script means and exactly how you do that. So once you anchor a script and there's a specific line of code you write to anchor a script, then all of a sudden the here package will learn about where all your data sets are stored in relation to that anchor. So if it's in the same folder as your script, it'll be able to find it there. Or if it's within a subdirectory of that, it'll be able to find it there. So I'm gonna repeat that, but with more of an illustrative example. So pretend I have a folder. It's just called R project folder over here. Within that, I have my cleaning code, which is just cleaning.r. It's just a simple R script. But I also have a separate folder called data. And this is where all of my line lists are stored. I'm some really exciting epidemiologist who's working with Ebola, COVID, and HIV. But suppose I only want to work with that Ebola line list, okay? So the way you drop an anchor in your script is through this line of code here. I say here, pun intended. I'm using that double colon to both load the here package and access the function within it at the same time. So I say, here I am, quite literally. And I put in my the file name for my code, the script that I'm working with. So I say, here I am, and now all of a sudden I've dropped an anchor in this cleaningcode.r file. And now the here package will use that anchor to find everything. So suppose I want to find that Ebola line list and import it the way I import it now. So I'm creating an object called line list. I'm using that arrow assignment operator to create that object. And I'm using the import function from here, not from here, sorry, from the Rio package. So the Rio package, I'm using that import function. And the way I'm locating that Ebola line list is I'm using the here function, and I'm saying, look for a folder called data. Data should be in the exact same place as my anchor is. And then within that data folder, look for Ebola line list.xlsx. So now everything has become relative to that anchor. And it looks for things based on that. So it's a very handy way. So you can see here, not once have I specified a file or a folder. Yeah, I haven't specified the directory. There's no file path over here that says like C : Aashna's computer : you know. So it's very handy. And now somebody else who has their folder structure set up like this can run this script on their computers, no problem. So it'll work on their computers despite not having that file path, because everything becomes
I
relative.
have a question regarding this. This
Yeah,
is
of course.
package syntax, right? But then walk around in other programming languages where we use relative references, for example, dot / image / and
Yeah.
in that data. But can I do that?
R, you'll notice, I think it depends on your operating system. It often
the slashes
considers the
back-
slashes are
forward or
backwards. So
That's a
that
problem.
differs. Yeah, that's a big problem with R. I haven't actually tried because I know in Python you can do dot and then
Dot
like
slash.
everything, but I don't think it works in R the same way, because your file paths are always characters. It'll be like in the quotation, and characters are mostly like absolute, so it won't be able to find that dot and then. But yeah, the slash directions are very
That's really
confusing
confusing.
in R. Yeah. Okay, so I think so it's good that we covered some material from tomorrow's session, so we'll be able to nicely skip this. Of course, if there are questions on this, we can revise as needed. But I'll spend the last few minutes just explaining some extra resources that you can use. Okay, I'll spend a few minutes talking about additional resources that are kind of good for everyone to be aware of. I know there's so many different resources out there. These are just a few handy ones. There are a lot of there are other better ones as well you can use. And that's something like actually talking to your peers who have used R before is a really good way of figuring out resources, because things that worked for them might end up working for you as well. So this is not the extent of extra resources. So RStudio itself has a tutorial pane that you can download this package called Learn R, and then that package itself actually walks through tutorials, which is really, really handy. And there's a link over there, and you can access that link and find out more. Similarly, there's a package called Swirl that has interactive courses that you can do kind of within your R console itself. And again, there's a link. There's lots of PDF cheat sheets available. Despite the word cheat sheet, it's not a bad thing to use. It's just a very good compilation of resources, and especially some of the things we'll talk about tomorrow. It's very handy because there's so many different functions, right? How can you keep track of everything? These cheat sheets kind of put functions that are often used together. That'll put it kind of together on a cheat sheet. So it's very handy resource to use. And there's also kind of bigger resources. So as I said, all of this material comes from the EPR handbook, which was linked on a previous slide, but there's two other really good kind of books and websites that have a curriculum for R. There's the R for Data Science book. This is a very foundational book. If you Google R and data science, it'll be the first one that comes up. And there's R for Epi's project. That's a website. It's a web-based resource, but that's very similar to the EPR handbook. Provides examples that are familiar to epidemiologists and kind of focuses on the use of R specifically in health and healthcare. So these are a few handy resources. I'll look online. Okay, yeah, we're good. I'll pause there. We have a few minutes to discuss questions, or if anyone had trouble installing R or RStudio, this would be a good time to tell us, and we can kind of help you out there so that you're prepared for tomorrow's session. So tomorrow we will cover lots of interesting stuff. We'll actually get to work with health data, fake health data, because real health data has privacy issues. We'll work with fake health data and actually learn how to make some basic tables and figures and go through some basic data cleaning steps and stuff, things that you'll actually hopefully use in your routine work. So I'll stop there. If any questions, let me know.
Thank you all for joining today. I think we're very close to the first session, and I know this is the very technical session, so we'll have a lot of questions and queries, but the session has been recorded, and we're here to give you any queries and then solutions. So even our facilitator Aashna is here. If you have any question, please share with us, and we'll share we have already shared the materials for tomorrow's session. Please join with us. But basically, the tomorrow session will be more focused on the practical issues. Thank you so much, and we hope to see you tomorrow.
Thank you.
Thank you.